Hello and welcome back to Friday Minis. Now, C programmers would have probably heard of the terms stack and heap. No, not the data structures. Of course, if you want to watch videos on those, I've got those. But we're talking about something different here. In C and C++, you can create variables. You can also specifically set aside space for your own, memory and storage. And these end up on different places called the stack and the heap. Let's start with the simpler of the two, which is the stack. Now, every time inside a function you say int something, you create a variable, whatever you have created goes onto the stack. Hopefully, this allows you to draw some parallels to some other places in which stacks are used. For example, every time you make a function call, all its variables and stuff get stored on the stack. So if that makes a further function call, that new function call goes on top, right at the top of the stack, just like how a stack works. When the newer function returns, it goes to the older one. So in this sort of context, using a stack makes a lot of sense. This, by the way, is also why the moment you leave a function, all the variables in that function are invalidated. They don't exist anymore. Because of this property, the stack is pretty performant. What that means is whatever variables you create on the stack can be accessed really quickly, and yeah, that makes it more efficient compared to memory that you've allocated separately. There is also one stack created per thread if you're doing a multi-threaded application. So what that means is stack variables across different threads cannot communicate. Also, stack size tends to be limited. So if you're creating very large variables, arrays and things like that, you probably don't want to put them on a stack. Let's now move on to talk about the heap. It's basically the opposite, right? It is global for your entire program, so different threads can work with stuff on the heap. It is somewhat slower because of, the heap-like manner in which the data is actually being organized. But the good news is there is more space available. So whatever large variables you want to create should live on the heap or elsewhere. We'll discuss that next. In order to put stuff on the heap, you are going to have to basically specifically allocate memory for those variables. So you'll be using things like malloc or new. Of course, don't forget, if you do that, you're going to have to free up the memory yourself later on. So that's the heap for you, right? It does not automatically allocate or clear space. You've got to do all of that yourself. Now, while the stack and heap are two prominent areas in which your variables and data can be stored, there are actually other areas as well. To read up more on that, pop open the video description. You'll have a link to a fairly good write-up on this topic. Now, the one other thing I guess I want to draw attention to is this area called the initialized data area. When you create things like global variables, outside of a function, that's where it goes. So earlier on when I mentioned large arrays, another place in which you can create large arrays is as a global variable outside of any function. Since this doesn't go on the stack, which has limited space, we are allowed to do that. It doesn't actually complain. So yeah, that's the big difference between stacks and heaps in the context of C programming. That's all there is for this episode. Thank you very much for watching, and until next time, you're watching 0612 TV with NERDfirst.net. Thank you very much for watching. If you like my work and are feeling generous, you can shoot me a one-time donation on PayPal or sign up for a recurring one on Patreon. Of course, you can simply like, comment, and subscribe. You know the deal. For more videos, links to my channel and a related playlist are on screen. Thank you for your support.